Hi everyone, my name is Juan Castillo, and I'm going to show you the results of my research in the research group of Professor Volker Krul at the University Hospital of Cologne. This was a project in collaboration with Lucas Sebeke, and we together worked on liposomal drug delivery of doxorubicin and cisplatin using MR-HIFU in a large animal model. So I think most of you are already familiar with the concept of high-intensity focused ultrasound, or HIFU. And we can use HIFU to achieve hyperthermic temperatures of 42 to 43 degrees Celsius in a target tissue within the body. And after injection of, for example, thermosensitive liposomes, which contain chemotherapeutical like doxorubicin and cisplatin, we can achieve higher concentrations of those drugs in the target tissue without increasing the cytotoxic effects on other not relevant tissues for the treatment. In this translational SWINE study in particular, we introduced a new formulation of temperature-sensitive liposomes with doxorubicin and cisplatin. The liposomes are based on a new lipid called DPPG2, which makes the liposomes thermosensitive. And we perform MR-HIFU hyperthermia experiments with these liposomes. So here we can see in the upper left part that we place the animal on top of the HIFU transducer so that the muscle biceps femoris, that was the muscle that we were going to treat, was right on top of the transducer. We also placed a ring containing MR visible markers on the skin on that side so that we were able to track the treated volumes in the MR system and also afterwards when we take the animal out and we take the tissue samples. The experimental timeline looked like this. At minute 0, we started the infusion of the temperature-sensitive liposomes. This went all the way to minute 30. At minute 10, while the liposomes were still being infused, we started the first hyperthermia treatment in a volume within that area of the circle with markers. This hyperthermia treatment went for half an hour. Then at minute 60, we started the next hyperthermia treatment, which also went for half an hour. And at minute 80, the animal was euthanized and all relevant organs and tissues were extracted. During this whole time, we took also blood samples to be able to track the concentrations of both the chemotherapeuticals and the liposomes, and that way so that we were able to get precise pharmacokinetic profile. This pharmacokinetic profile looks like this. The red circles are the circles for doxorubicin. The yellow markers are for cisplatin, and the gray markers are for the liposomes in the case of cisplatin and in the case of doxorubicin. So we can see here that we get, in all cases, a steady increase all the way to minute 30 when the infusion stops. And from there on, we see a very slight decrease in concentration in the bloodstream for the liposomes, while the concentration of the APIs, cisplatin or doxorubicin, both decrease a little bit faster than the liposomes themselves because there's always a little bit of leakage. Anyhow, the decrease in concentration is a lot slower than it would have been with the free drugs, of course. So we, as I said before, we perform the hyperthermia treatments starting at minute 10 and at minute 60. And the results of these hyperthermia treatments can be seen here in this slide. So after we extracted the relevant tissues and analyzed the concentration of the drugs, we could see that for doxorubicin, we were able to achieve 15 times increase in concentration in the muscle compared to a sample of untreated muscle, which was taken from somewhere else, in the same animal, of course. And we could get, for the second treatment volume, an increase of 7 times also compared to the untreated muscle. For cisplatin, we don't get such nice increases in concentration, but we do get good result of 2.5 times for both treatment volumes, which is also nice example for the success of this approach. So this is pretty much the end of my presentation. I would like to give you some conclusions here. So we were able to perform peak experiments with HIFU hyperthermia and thermosensitive liposomes successfully. We could see an increase in concentration for dogs and a slightly less increase in concentration for cisplatin, but both were actually very good results. We could see a very nice pharmacokinetic profile that showed the desired prolonged circulation time. And right now, drug delivery experiments in pigs with hyperthermia in moving abdominal organs are in planning and will be performed soon. This is specifically relevant in the case of the pancreas, because as you might know, the pancreas is a very important organ where a lot of approaches are being investigated right now to achieve drug delivery, specific drug delivery in this organ. So thank you very much. In case anyone has any questions or wants to contact me, please feel free to look me up in LinkedIn. Here's my LinkedIn profile. And yeah, and that's pretty much it. Thank you very much for your attention.